So we will be having Catalin Frolio and Evan Williams to do a hands-on Arduino workshop for beginners. Catalin Frolio has a bachelor's from TCNJ and a master's from Villanova in electrical engineering with a concentration in high-frequency systems. She currently works as an electrical engineer at Lockheed Martin in Morristown and is the chair of the IEEE Young Professionals Princeton/Central Jersey section. She is also an adjunct professor with the Rowan Electrical and Computer Engineering Department. And Evan Williams began his career in 10th grade at Princeton University's Microprocessor Lab. This laboratory taught students how to interface 8-bit computers to real-world devices. After graduating from Thomas Edison State College, he worked for 25 years in computer software and servers. After spending 10 years developing websites, his career came full circle at AT&T Middletown, where he worked on 3 large web dashboard projects. He also holds a degree from Rutgers University in computer science and is a ham radio operator. We look forward to the workshop, and I'll give it to Catalin and Evan. Thank you.
All right, let me see my screen. Okay, there you go. So anybody has the board at home or the Arduino software downloaded? It's kind of gonna be challenging to make this hands-on, but I'm gonna try my best. Usually this is a 3-hour workshop. We have a TCF, and I usually give out people their own boards and so they can follow along, but I try to do my best. If anybody has the Arduino, please make sure it's connected to your computer, laptop with a USB. We're really not gonna do anything really challenging. My goal is by the end of this lecture, you have an idea how to blink an LED, how to connect your Arduino, have some basic concepts of what the Arduino is. Everybody can hear me okay? Right.
Yes, we can hear you.
Okay, all right. Because last time I got disconnected halfway through my presentation and I didn't realize it. So now I have better Wi-Fi. So the plan is I'm gonna cover the first hour of this workshop. Then Evan gonna take over at 1:30, around 1:30 is the second part, right? So let's get, thank you for the introduction. At least I don't have to introduce myself. Let's get started. So the plan is to cover some basic concepts, what's Ohms Law, Arduino hardware, some basic components, resistors, LEDs, what's pulse width modulation, how to set up your ID, how to connect to your board, basic functions that you can use. And like I said, few examples. So the Arduino actually has some built-in examples. So you don't have to write the program. So you can just blink an LED because your board actually has a built-in LED on pin 13. So you can just upload the code and blink it. So you can test your board. And a little bit more advanced, the fading, or again, it's a built-in program. So this will use pulse width modulation to fade your LED, and which makes it look like it's actually analog signal instead of digital. And we can also do serial communication example, a hello world. Like I said, this is designed for people, mostly for students or people who don't have a lot of experience with electronics. So if you are an electrical engineer, this might be a little boring for you, so apologize for that. So this is your board. I usually recommend buying the Uno because it's the most, the cheapest usually, and it's easily available. And we're not gonna do anything too advanced, so you don't need a very expensive board. I used to buy mine on eBay, although I haven't been on eBay a long time. So I used to buy a starter kit for less than $20 with a board, with an actual board in it, with resistors, with LEDs, some a little breadboard. So I wouldn't recommend spending hundreds of dollars on it. So if you just want to buy, you want to get started with it, make sure you don't spend a lot of money. You don't have to get the original Uno, which you go to arduino.com. So it's usually a little bit more expensive. But like I said, you can go on eBay, you can go on Amazon or wherever you go shopping, and you can get a reasonably cheap one. It's open software and hardware, so you don't have to worry about, it's not the original one, that's fine. All right, this is the pinout. You don't have to know every pin on this board. You really have to be familiar just with the pins, the digital analog pins. So you have to know you have 0 to 13, okay, that's 14. 14 digital pins. You have to know where the grounds are. So you can see there are 3 ground connections. We'll explain that later, why you have to know the grounds. And also there are some analog inputs, outputs, so 0 to 5. So there are 6 analog pins on the left-hand side, and there are 14 digital pins. And some of those with the tilde next to it, you see that those are capable of pulse width modulation. We really don't care about any other, maybe the reset button. You care about the power jack. You can power it externally with some power supply. But the USB, if you connect it to your computer, you will get your 5 volt you need through your USB. So there are many, many boards available. Like I said, I wouldn't recommend buying the most expensive unless you have a very advanced project. The Uno is more than good enough for you. Should be under $20, $30 maybe. I think even on the website, it's $20 without any components. So there are other ones. There are the lily pad, which actually you can sew it into fabric. There are others with more memory, but like I said, we usually not gonna go that advanced. So it depends on your project, what you decide to buy. But like I said, I wouldn't spend a fortune on them. The main idea is to get it cheap and just play around with it. So what's an Arduino? Arduino basically is a tiny computer. You see that little chip that looks like a little spider in the middle? That's your brain. That's the brain of your computer. And you can just program it. And actually, if you want, you can even build your own Arduino. You can buy the microprocessor, an oscillator, and some crystals, capacitors, and you can actually build your own if you're willing to Google how to do that, which is pretty cool. I actually did one of those. So these are the specifications. So a recommended operating voltage is between 7 and 12 volts. So you don't want to go above 20 volts maximum and less than 6. So although it does work with the 5 volt, what you get through your USB. There are 14 digital pins on the Uno. This is for the Uno. Of course, the other boards, some of them have more, less. You have 6 analog inputs. The maximum current is 40 milliamp with the digital pins. Memory, well, it's good enough for us, 32 kilobyte for that little chip. That's pretty good. And we really don't care about the weight and the height. So what's the circuit? So you probably remember in high school, learned that in order for the current to flow, you have to have a closed loop. So we have to have some kind of voltage source. In this case, like I said, your computer is gonna provide your 5 volt for your board, but you can use some kind of battery, some kind of other voltage source if you want. Just make sure you limit your voltage and your current. And usually you're gonna have some kind of components. We're gonna explain what LEDs, resistors, you're gonna have some wires, we're gonna use breadboards. I don't know if anybody has some of these at home at hand, actually. So here's the basic example of a closed circuit, very, very basic, okay. So you just have your voltage source and you have to have a closed loop. So you have to have a connection in your circuit in order to have current flowing. And this picture shows current flowing from positive, from negative. That's the conventional current flow, but actually electrons move the opposite direction. But in reality, we don't even care as long as there is a net flow, and that's enough for us to have a closed path for our circuit. We don't care which direction the current flows. So what is voltage? It might be basic, some of you might know this, but like I said, this lecture designed for people who don't have any idea about circuits and electronics. So the voltage is basically a potential difference between 2 points in your circuit. So you have, that's why we said you wanna know where your ground is. So that's gonna be your reference point. So when you look at this water tank, so your ground would be the bottom part, which represents 0 volt. And the top of your water tank would be, for example, 5 volts. So this voltage difference, potential difference in your circuit makes it possible for the current to flow. So that's the water here would represent the current flowing through your circuit. So if you don't have potential difference in your circuit, you don't have a voltage source, your current cannot flow. You cannot blink your LED or do other cool projects. So again, in this example, well, of course, the voltage named after Alexander Volta, and the symbol is V, and in volt units is volt. The current is, when you look at this example, this tank example, the current would be actually the water flowing through your circuit, well, not circuit. Please don't do that. Don't put through water on your circuit. So the current is represented in this example as water flowing through your tank. And that's what moves the electrons so you can have a closed path. And the current, the symbol is I, and the units is amperes with capital A, usually represented with A. Probably heard, you know, this component needs this many milliamps or amps, well, usually milliamps. For example, an LED would need about 20 milliamps to light up. So, and what's resistance? Resistance in this example represented by the thickness of your pipe. For example, if you have more resistance, you will have less current flowing through your circuit. So resistance is measured in ohms. Units are represented with R. So I wanted to explain all this because it's important to know Ohm's law when you work with circuits. You usually wanna know how much current your circuit is getting, you wanna limit. So you wanna use some resistors, for example, to limit going to your LED because you don't wanna burn out. Well, they are actually pretty hard to burn out. They are not like the light bulbs. So they are pretty good, but still usually wanna limit the current going into your components. And this is how we calculate it. This is this simple triangle shows you that voltage equals current times resistance, I times R. Pretty simple concept. Actually, it's something we actually teach in college. This is the first law most electrical engineers learn. And you can see, you can calculate the current is voltage over resistance, resistance, voltage over current. So if you know any of these two components, you can calculate the third one. So for example, you have a 1 volt potential and 1 ohm resistance. That means, this is a very simple example. That means you have 1 amp of current flowing through your circuit. In this example, in your water tank. But for example, if I increase my resistance, so then by a magnitude of 2, then your current gonna decrease with a magnitude of 2. So they are inversely proportional. So your current gonna be 0.5 amp, which sometimes, like I said, you wanna limit the current going into your components. Usually we use, it's easier to use a breadboard, and we'll come up with a simple example like our first one with the LED. You don't wanna design a printed circuit board right away. You wanna prototype your circuit, and these little breadboards are very useful. Basically, you just have a piece of wires inside. You can see the inside of them. You don't see it from the outside, but you have wires, a piece of metal there, which is conducting. So you don't have to have wires connecting your components. So you can just jumper, for example, in the middle, you can put an LED in there and jumper one side to the other. Very useful little tools, and they are pretty cheap too. So these are the resistors. They have different forms, they different sizes. There are some surface mount resistors. And actually this is my, usually my favorite part in this workshop, when I usually give people some resistors and we use a digital multimeter and try to figure out first by looking at the color code. So let's look at this 4-band color code. All the colors represent a number. For example, black is 0, brown is 1, red is 2. So when you look at this 4-band color code, the first 2 digits would represent a number. For example, the first guy would be 1, brown is 1, black is 0. And in the 4-band code, the third one would be your multiplier. So that means 1, 0 multiplied by what? 1K. K means 1,000. So this is a 10,000 ohm resistor. But the last line here, when you look at it, the most easily available is the 5% tolerance one. So this guy is has a gold band at the end, which means it has a 5% tolerance. So this resistor, usually like I said, give people some resistors, they try to figure out what the value is, then we use a multimeter. And for example, this one is a 10 kilo ohm resistor. So the value might vary between what, 9,500, 10,500. So you exactly not gonna get, when you have a resistor, you're not gonna get an exact value what the band tells you. It's actually very difficult to manufacture something exactly that value. So you're gonna have some kind of tolerance between the values. As you can imagine, the tighter the tolerance, the more expensive the resistor is, which when you have hundreds of resistors, for example, in your circuit, that can make a big difference when the value, not getting the value what you're expecting. So it's kind of important to pay attention to that. But in our case, we really don't care if the resistor is 200 or 300 or 250 ohms. But when it's a bigger project, you want to pay attention to tolerances. Another important component, important or exciting, is a LED, which stands for light emitting diode. So the LED is basically a component that lets current flow one direction. And it's very important to know, usually, where's my next drawing? You would have a negative cathode and a positive side. As you can see, I'm not sure if you can see it from this picture, the negative side, the negative leg of your LED, your diode, is actually a little bit shorter, and the positive is longer. That's on purpose, so you know which way to put it in your circuit. Because if you put it in backwards, your LED just not gonna light up. So you wanna make sure your negative leg, which is the shorter one, as you see on the picture, goes to the ground, so to the lower potential. So the current can flow through your LED. Also, this picture shows a resistor. A 220 ohm is a good one for example, for a 5 volt input, which limits your current to what you wanted. But actually, well, 300, even 500 is fine. But you usually want to protect your LED from overcurrent. But like I said, this 5 volt is not that much, so you're not really gonna burn it out, but it's always better to be safe than sorry. So again, you want to pay attention to the direction of your LED. You want your negative leg going to the ground, to the lower potential. Of course, there are many other LEDs, but at this point, we only care about the light emitting diode. Let's see. Well, of course, we're gonna use wires too, because the breadboard, you wanna jumper your board over to your breadboard. So actually I do have some wires. I don't know if anybody has any wires at home. So you might wanna connect some of your wires to your pins and to your breadboard and to your LED. But this board, actually at this point, if you have a board, you might be okay because, like I said, you do have an LED built in at pin 13. So we can actually just blink that one just to demonstrate it. So I'm not sure who has it downloaded. They always change it, the interface, but it's a little bit different for Mac and PC, but basically you have the same components. So you have something to check your code for errors. So this code, which they usually call Sketch in Arduino, like most programming, it's very sensitive to errors. So even if you write a word in lowercase instead of uppercase, you might get an error. So you wanna click on that check mark, which verifies your code before you upload it. And then your program actually gonna try to tell you where your error, at least the line you have an error on, then you can try to figure out what your actual error is. Then the other important one is the upload one, which uploads your sketch, which is what the Arduino calls a program, to your board. New, obviously, create a new sketch, and open is again obvious. Opens, you can open an example and you can save. And you also have a serial monitor, which we're gonna use when we do the hello world example. So actually it should show how to connect it. Well, still some, all right. Let's talk about what a sketch is. So the sketch is basically what Arduino calls a program. So if anybody has the ID up, where's my Arduino? So let me open it up. If you go to File, Examples, Basic, and there's a bare minimum. So if you open up that code, you see that at the minimum, you have to have a void setup and a void loop section. So very important, you cannot make sure there's no spelling mistakes. This is, for the Arduino, this is the minimum you have to have. So in the setup, obviously you set up some variables at the beginning. You only do it once, and the loop just keeps looping until your power is lost to your Arduino, just keeps looping. So this is the minimum in your code. Where's my PowerPoint? Okay. This is the minimum you have to have. I don't know how to go back. Current slide, there you go. All right. So sometimes you want to use comments, most coding, you remember, well, some of you know, it's useful to add comments. You might want to add, let's say in a year from now, you want to look back to your code and what was I doing? I have no idea. So you might want to add some comments there. So the comment is actually something that's not visible to the to your board. So 2 slashes would be a single line comment. For example, you can explain what you were doing in that what you were trying to do in that line. And you can also add a multi-line comment, which is a /* as the beginning and * at the end. So you can include multiple lines. You can write a little essay if you want there, and it's not visible to your to the sketch. So it's just something for humans to read. Let's say, okay, this code gonna blink an LED on pin 13. I wrote it in, I don't know, 2022, you know, stuff like that. Inside the multi-line comment, you can add single line comments, but you can add another multi-line. So this is my sketch. So what are variables? So the variables, the way I like to explain it is like a bucket which holds some kind of value. So, and also there's a limit. You have to define what you put in your bucket, and there's a limit how much that bucket can hold. So for example, I'm defining this variable, input variable 1, and give it, you can give a value, whatever, equals, so, well, okay, input variable 2 equals 0. So which integer, int, means it's a whole number. So this is the type, this is, the second one is the name, and the value you're assigning is, for example, LED pin equals 13. So that means your pin gonna be pin 13 that you're gonna talk to. It's gonna, one interesting concept is the variable rollover. Like I said, as you imagine your variable as a bucket, there's a limit how much you can put into your variable. For example, an integer. Oh no, I have a better picture for that. So an integer can hold a value between negative 32,768 and positive 32,767. So for example, if I define this integer x as 32,767 and try to add 1 to it, you're not gonna get 32,768 because it just cannot hold, your bucket cannot hold anymore. So what it's gonna do, it's gonna go back to the first number, which is actually a negative number. So you might expect to get, when you add 1 to your value, to get 32,768, but you're actually getting negative 32,768. Like I said, your bucket, your variable can only hold so much. So what it's gonna do, just gonna roll over to your first value, which is actually in this case is a negative value. It's actually something that happened to us at work, and we had no idea what was going on. So it's an important concept. So there are some rules when you're defining your variables. It will only hold the data type you define. So you, for example, when we said integer, it's a whole number. So when you define your variable, you have a type, which is integer, constant, double. There are many types. You have to give it a name. You usually want to give it some useful name like LED pin 1 or something like that. There are some rules to this. You cannot start with a number, must start with a letter, no keywords. You cannot use keywords as variable names. Of course, when you try to run your code, you're gonna get an error for that. I mean, I don't know all the keywords. You can always look them up. What are keywords? I don't know all of them, but some of them, you know, add, constant. You can't use, for example, constant as a variable name. And it's important to make your name, variable name descriptive. And one interesting stuff, which you don't have to do, sometimes we use what we call a bumpy case or camel case. For example, when you write, I don't have an example. So here's an example of bumpy case. So your MyMultiply function. So the first part of the my starts with a lowercase, and every word starts with the capital letter. So this is what we call a bumpy case or camel case. Just so it's easier for you to see because you cannot put spaces in there, and some don't even want to do underscore. It's just easier this way. But you can call your variable, your function, whatever you want, as long as obey these rules. So what are the functions? Let's do a simple one. So this is my function. So you have to have something that it returns. So the first one, integer, is that the type of value that your function going to return. So this function going to return a whole number. The name of my function, MyMultiply function. So I'm guessing it's going to multiply something. It's very descriptive. I like that. And you're gonna have some inputs. One input is X, which is again, a whole number, integer Y. And inside your function, make sure you pay attention to everything to the curly bracket. So the beginning of the function is here, one curly bracket, and the other function, the end of the function is the other curly bracket. So everything inside of that function will get executed when you call this MyMultiply function. So for example, in your code, you multiplying two random numbers 100 times. You don't have to write this down 100 times. You're just gonna call this function. I'm gonna call MyMultiply function 1, 2, and it's gonna give you the value integer, your result, going to be 1 times 2. So of course, this is more useful if your function is larger, more complicated. Again, you don't have to write it 100 times or 10 times in your code. So here, this MyMultiply function takes your input, which is X and Y, and will give you a result and will return this result. Like I said, if I call MyMultiply function 2 in parentheses 2, 3, it's gonna return 6, hopefully, right? 2 times 3? Yes, all right. So here's an example. If you happen to have your Arduino or your bare minimum sketch, you can always type these. Actually, we usually do this during the workshop. So if I have my bare minimum, you open a bare minimum. Okay, so you can always, into the void setup, you can type serial. That begin, make sure you spell it right, unlike me. 9600. So make sure you, for example, it's your serial. If you don't type it capital S, you're gonna get an error. And the loop, you can type, well, actually I can type all this in your loop. Okay, where am I? Let's copy. Actually, we should show how to connect your board first. Oh no, that didn't copyright. Anyway, integer of the spaces, didn't like my spaces. So integer 2, 3, multiply. Okay, and then I'm gonna define my function at the end. This is the example of your multiply function. Where is my code? Of course, it's not gonna like my spaces again. So, yep. Integer 2. Did I copy? No. Yeah. Anyway, I'm gonna try to post this slide so you can play around with this at home. Actually, first I should show you how to connect your board. So what this gonna do, this function gonna call your multiply and gonna display the value in your serial port. First of all, I should show you how to connect to your port. No? Yes. Okay, almost there, I promise. Okay, so again, another very useful programming is the Ecells statement. So here you can define, make sure you pay attention to the where the parentheses are. So for example, here you can define some kind of threshold. And if this value is above this threshold, you can set your pin, whatever pin you defined previously. This is just a snippet from your code. So you set your pin high, which means you apply 5 volt to that pin. Let's say LED pin is defined at the beginning. Int LED pin equals 13, that's our built-in LED. So you can set that high. High just means you're applying 5 volt or 1. And if the value, some value you're reading in, for example, from an analog pin is less than, then you would turn your LED off. Where are we? So another important built-in function is the pin mode. It's actually built in, you don't have to define it. So at pin mode, you can just define a specific pin as high or low, which high would be, 5 volts. You're applying 5 volt to that pin. Remember we had how many? 14 pins, 0 to 13. So you can define a pin. Pin number is the pin would be your pin number. And the mode is input and output. You can read in a value, or you can put out a certain value onto your pen. So the other important one is digital read, which would read in a value from your pin. And then you just give it to a pin number. Again, digital write is similar. So you just give it the pin value and pin, for example, digital write 5. So this means pin 5 gets a high voltage, which is high volt, or digital write 3 would mean pin 3 would get 0 volt, which is ground. Analog read. So again, your analog read function would just take a pin number. For example, remember we had how many? 4 or 5 analog pins. So you can read the value of an analog input with analog read, just giving the pin number. And you can actually do pulse width modulation. So you would give analog write, takes as input as a pin and a value. So you can vary the value between 0 and 255. So actually, in this case, you would give something between 0 and 5. It kind of looks like it's an analog value, even though it's not really. We're going to talk about pulse width modulation because your computer is only capable of doing zeros and ones, 0 or 5. Okay, this is how we connect. This is the important. I should do this at the beginning, actually. So how to connect to your Arduino. So hopefully, if you have a board, you have it connected to your USB, and you can open your Arduino IDE. Let me close everything. I don't want to save it now. So you can open your IDE. You can go to Tools, Board. You have to do 2 steps. You have to select your board you have. So you go Tools, Board. Mine already chose the Uno because I'm already connected. But if you had something different, you would choose, some different one. Make sure you have a check mark or a dot next to it. So I'm connected to the Uno. Then you would go Tools, Board, Port. And then you have to choose your port too. Make sure you might have a few ports pop up. It's different for the Mac than the PC. So mine are already selected. It's usually the last port. And if you don't know which one, just keep clicking through them. So you have to make sure you have a check mark next to yours. So two things you have to choose. You have to choose your port number. Why can't I click on it? Okay, port. No, I can click on that. So Tools, select your board. Make sure you have a check mark next to your board. Mine is an Uno. And you select your port. Make sure there's a dot or check mark next to your port. Okay, now I'm connected to my board. Like I said, it's different with Mac. Of course, Mac always has to be different than PC. And again, if you don't know which port, you can always just unplug it and plug it back in and see if it pops up your port. And if you don't know which one exactly, it's usually the highest number though. So if you want to follow along, so you can, now we have our board connected. You selected your board, you selected your port number. So we can just look at an example, the most basic example, even if you don't have a board. Okay, not this one. Oh no, did I close everything? No. So I can go to File, Examples, Basic, and I go to Blink. So if I open this code, they always change it around. Actually, I don't even like how they have this one written. So what this code does, you see all the comments at the beginning, they are kind of faded. It's not visible to the computer. This is just for us who wrote the code. What does it do? And you have to have a void setup. See the void setup function and the void loop. It has stuff in it. So your void setup has pin mode, which has this built-in LED built-in as output. So actually this LED built-in is a new thing. It's already defined. It's pin 13 on your Arduino. Actually, I prefer defining a variable. What I would do is I would do integer LED pin equals 13. And I would put that here, but this is fine right now. Because this way, if I want to pick a different pin, for example, next time I want to use pin 10. If I would want to use pin 10, everywhere I have LED built in, I would have to change it to pin 10. So, but if I define the variable at the beginning, like integer LED pin equals 10, then I would only have to change it once at the beginning, that's the whole concept of defining a variable. But anyway, this is good enough. So when we go to the void loop, what they do is write to this LED pin 13 a high value, which is just 1 or 5 volts. And you have a delay because actually this would be very fast for us to actually see this. We need a little bit of delay to see what's happening. So that's actually 1 second, it's a millisecond. So then it does a digital write on the same LED pin and sets it to low. So now you don't have a voltage potential difference because your one end of the circuit will be connected to the ground, and this input now it's connected to ground too. So you don't have current flowing. So what this does is just turns your LED off. So let's check this for errors. Shouldn't have any errors. If you click on the check mark, it's compiling your sketch, looking for errors. If you want, you can actually make mistakes in your code. So you shouldn't get any errors. So let's see, let me make a mistake. Let me change pin mode to lowercase m instead of capital M. Now I try to verify this code. What is it gonna do? So it's telling me pin mode was not declared in this code. So it doesn't actually know what's happening. So it's trying to tell you you have a mistake in pin mode. So let me change it back to capital. But that's what happens when you have an error in your code. So I'm going to change this back and check it, verify again. Okay, shouldn't have any mistakes. Now I'm going to upload it. Click on the upload button. Might take a second. It's compiling. So it's uploading. All right, I think it did. All right, yeah. So it uploaded to my, I did put, I don't know if you can see it. Can you see this? So I did put an LED. You do have a built-in LED there, which is blink. It's very hard to see. So that's why I put my own little LED there. So you can see that pin 13 is blinking. So usually during the workshop, what we do, we play around with this value. For example, I can change this delay value. So now it's blinking kind of slow. So if I change this delay value to, for example, 500, half a second, and I upload this, let me verify it, make sure I didn't make a mistake. Verify your code, upload it. Now that I uploaded it, it's kind of blinking faster. Can I see it? Am I showing it? Okay. Oh, no, oh, okay. Yeah. There you go. It's blinking faster now. So let's go back to the slides. PowerPoint. All right, so here we are. So if you had a board, a breadboard and a resistor and an LED, this is how you would hook it up. So you would have a ground. We usually use a black wire, but it doesn't matter. You can use any color. So you would pick up ground of the board, connect it to your resistor, 300 ohm resistor, and then remember you would connect it to the short leg of your LED, otherwise it's not going to light up. So you remember, follow the lines in your see your breadboard, it's green. That means this is where it's connected. So the resistor would go to your LED, then you would jumper it to pin 13. And once you upload this sketch, your LED would light up. It's so exciting. It's not that exciting virtually, sorry about that. So this is how you would hook it up. These are some LED code examples. Of course, once we have this, the challenge would be to connect 2 LED pins. That's why I said I didn't like this code that had LED built-in defined. What would be better, like this guy. Can you see that? So here they define a variable integer called LED, pin 13, and you call that variable in 3 times here. So if I want to change that, for example, to pin 12, I wouldn't have to change it 3 times. I would just change it here. Again, you can add a second one. Is there an example? Yeah, I'm ruining it, but in the workshop, I usually ask people to try to set up another pin. So this is how you would do it. For example, I would pick pin 12 as for one of my, for this example. So one of my LEDs would be connected to pin 12, or other one would be connected to pin 11. And I would turn one on and delay for half a second, and the 2 at a time. So you would blink both of them at the same time, or you can play around, turn one on, turn the other one off. So lots of fun. Again, kind of tough to do it virtually. So now we know, anybody actually doing it or having problems connecting to it? I don't know if who has boards. Of course, now I have at home at least 20 of them. So I wish I could. Hopefully next year we can do it in person. It's I promise it's definitely more fun in person than virtually. And yeah, it's much, usually it's 3-4 hours we spend on this. So probably I've been talking about digital and analog pins, and probably many of you know what the difference is. Basically, digital is just discrete numbers, like digital clock. You see discrete numbers, and analog is just a continuous Oh no, I'm running out of time. Oh, that's okay, let me finish this. So digital, you have two, I should make this larger. That's okay. Let me see these slides. Oh, all right, so digital, you would have two values on and off. This is what your computer sees. You will either have a 0 or a 1, but most things in real life are analog, continuous. So you have to quantize to break it down into digits. That's what we do in computers. This just shows the difference between digital. I'm not going to go into details. So other important concepts, you remember we said there were some pins that had a little tilde next to it. That means they can do pulse width modulation. So basically it's kind of like cheating. You're making a digital signal look like it's analog. So for example, here you can see a certain percentage of the time the signal is on, then it's off. So basically modulating this signal, the period is when the difference, all right, slow down. I'm trying to rush here. So when the period is when your signal starts repeating itself, and the percent it's on and off defines how much you're modulating your signal. For example, here, a 0% duty cycle would mean you call the analog write 0, so it's never on. So here, the next one would be 25% duty cycle. So your signal would be on for 25% of the time, which is equivalent to analog write 64, and on and on. Let's say analog write 255 would be, it's always on. So it's basically just 5 volts. We've been talking about serial communication, but serial simply means one after another. So like I said, your computer only sees zeros and ones. So it communicates with your USB port. It's just sending data serially, one after another, zeros and ones, which is kind of hard for us to understand. That's why we have this Arduino IDE that explains, that converts everything for us. So I think we're almost done. When do I run out of time? 1:20?
So actually we have time blocked out until 2:35, so you have plenty of time.
Yeah, I know. I know Evan. We agreed with Evan that he's gonna take the second part of the.
Oh, I see. Gotcha.
Yeah, we broke it up since you know I really can't do it. A lot of hands-on. He has a little bit of demonstration. So I think I'm gonna stop around 1:30. Evan, is that good for you?
Yes, it is.
Okay.
So someone needs to start the video for me.
But you have to start it. You have to share your.
I seem to be locked out right now.
Yeah.
Start. You cannot start your video because the host has stopped it.
Okay.
Well, let's see. If we need to, maybe we'll make you a host. But I think as soon as Catalin stops sharing, maybe you'll be able
to. When I stop, you can take over.
Great,
I don't know if you want to take it.
I have a few things for everyone.
All right, I'm just going to stop at 1:30. We'll see how far I go. Let me go.
That was great. That was a great, they're great slides, Catalin. I really enjoyed them.
Yeah. Let me just go through this fading one. I think this is a good example. This demonstrates the concept of pulse width modulation. So again, just give me another 5 minutes and then I finish.
Sure.
All right. So this fading example, again, you can just go to your Arduino IDE, go to File, Examples. I think it's the basics, and fade. So this is a little bit more advanced than the blinking one, but this demonstrates the concept of pulse width modulation. So what the code does, if you want to step through it, so all you need, again, you can just use your built-in pin 13 LED. You don't have to have your breadboard connected if you don't want to. So what this code does, it defines, we know a variable LED, which is on pin 9, defines a variable brightness. It starts at 0. And then we're gonna increase that amount by the increments of 5. So in your setup, you remember you have to have the void setup and void loop. So in my setup, I just define this pin as an output. So I'm gonna just continuously output values into that pin, which is pin 9. You can pick whatever you want. If you want pin 13, because you don't have an LED, that's fine. You can change this value to 13. So then everywhere you see LED in your code, that would be pin 13. So in your loop, what it does, rise the value of the brightness. So here we start out at 0. The first time we go through this loop, we add 5 to this brightness every time until you get to either 0 or 255. So first we're gonna go 0, 5, 10, 15, up to 255. Then it's gonna switch the value to a negative value. So, which is Faderman gonna be, then it's gonna subtract the 5 from this value. So you go to 0 to 255, then gonna subtract 5 every time and go back to 0. And it introduces a 30 millisecond delay. So we can actually see this. Let me try, oh, do I have it connected? No. Let me try to upload this. Let me change the 9 to 13 because I don't have it connected to 9. So I'm gonna connect to 13, verify my code, upload. Let's see if, am I showing it? I don't even see it. Can you see my board? It's not uploading. Did I upload it? Upload. Oh, okay, it's uploading now. I'm seeing my screen. Oh, kind of hard to see. I think it's too bright. I don't know if you can see my. Oh. So it starts fading. Oh. Okay, I'm horrible at this. So I think it's too bright. You can't really see it. It gets brighter and brighter and then fades away. 13, right? That is 13. Yeah. So that's what it's doing. That's the last one I wanted to show, sorry. Also in my workshop, we usually do another example, but which is a 7-segment display. I just give people to their code and they upload it. It counts back from 0 to 9, which is kind of cool project, but I'm not gonna do that now. Here I just show some, this is actually how you can build your own Arduino. You just need a few oscillators and some crystals and some capacitors and resistors. Actually, I've done this before. It's kind of cool. So this way you can shrink the size of your board a little bit because, you know, some of them are actually pretty big. And here, this one I found a few years ago. What is it called? Arduino block. So this is like a block programming. It would be really great for some younger children. So they basically use this as a puzzle. So they can set up their own code in this Arduino block and they can just program, you can just connect this to your Arduino, and this would be great for some younger children. If you want to know, the instructions are here, how to download it. And this is it. You just see some possible projects. So like I said, there's some of these boards, this little pad, you can sew it into fabric. You can make some light up pumpkins, whatever it is, some moisture sensors for your plant. like I said, it's open source and you can find so much online. There are so many people who are interested in this, and you can just find code and just play around with it if you're, not an expert at coding, which I'm not either. So, all right, I'm gonna stop. Evan, if you want to take over. Anybody has any questions?
Yeah, are those slides available to download or to look online?
I'm gonna send it to TCF with Dr. Katz. Is there a place? Well, yeah, I try to. Yeah, I figured it out how to send it. Yeah, it's not up there. I don't think so. Where's my Zoom? Okay, let's see. So this is all I wanted to say. If Evan, you want to take over?
Oh, sure.
Or you
sure.
want to take a break? Anybody
No, I'm
needs
good.
a break?
I'm good. Oh, would anyone like a break?
Depends how long you're gonna. I think we have till 2:25, right?
Okay. I have some material.
Okay. Do I have to stop sharing?
I don't know.
Where's my screen?
That was very good, Catalin. I really enjoyed.
It is more fun when it's in person.
I know, but we have to do what we can.
New slide. New share. No. Let me unshare. No. What did I want? Stop share. Yay! I figured it out. I think I stopped sharing. Did I?
Great. Let me see if I can share my screen.
Share screen. Did I? I think I did.
Share.
No, oh, that's yours. Okay, good.
Yeah. The host stopped my video, so I don't know what might have happened to my video. Okay. I'll start my video. There we go. Oh, okay, great. Okay, here I am in my shop. My name's Evan Williams, and the bio's a little old, but that's good. I'm glad to be here. Let's see. I have slides that I gave last year that were pretty good about building your own Arduino circuits, and Catalin had mentioned those in the last part of her talk. So since probably some of you are familiar with Arduino already, I just wanted to reiterate a lot of what she said and sort of demonstrate it, go over some of these things again. Maybe take some questions and help to clarify some of the material. Before I start, let me ask you an engineering question. Do you have to know how a car works in order to drive it? What about a calculator? Do you have to know how a calculator operates in order to add two numbers? That's just something for you to think about. My point is that Arduino is a fun way to get started in electronics and build a lot of cool projects. And it's there's a lot of things that you can go deep with, but the basics can be pretty easy. So that's the overview for what I have to say. I have a Nano here. I wish the cameras were better on these cell phone, on these laptops. I thought I'd start by putting Blink on the Nano. So I have an Uno too. I'm going to start up the Arduino IDE and go over some of the things you need to do. And let me share. Can you see my screen with the IDE on it, or is it my picture right now? Oh, you can see my screen. Great. Okay, so you're looking at the Arduino IDE. This is available at arduino.cc. If you've gone there, let me go there with you and show you where to go to get this IDE. Does everyone know what IDE stands for? It's an interactive development environment. This is the Arduino website. Now, Catalin mentioned that for $20, she is or was able to get get Arduino Unos on eBay. I haven't tried to buy any Unos lately. I have had trouble getting Arduino chips from Atmel chips from one of my suppliers, but okay. So anyway, let's drive through it. You have to go to software here on the IDE and download the latest IDE for your environment. Now, sometimes it's not as simple as you might think, but here it's pretty easy to get the Windows 7 and newer installation package. That's the first one of the download options right here. But notice there's also Windows apps. I have not had a lot of luck with Windows apps. I have used Linux and I have used Mac. So depending on what platform you are on, you may want to use choose the right IDE. Now let's going back to the IDE I have installed on my computer. If I go help about, like in any program, it'll tell me if I have the latest and greatest version. Oh, it says 1.8.16. So let's see that again. 1.8.16. So I think I do have the latest version. It's up to 1.8.19. So just because I don't like to be behind the times, well, I guess I can't install a new one right now. I'll spare you that. But if we were having a real session, I think I would go install the latest one. It's important to stay up with the latest technology. So for instance, Arduino Uno is still around, but they have changed a little bit. And there are new Unos out there that are Uno plus Wi-Fi. I have not kept up with all the new Arduinos that are out there. But Catalin's slides were pretty good in that she had a lot of examples of the different sorts of Arduinos that are there. And if you go to the store, you can shop for some of them. To keep it simple for everyone, I would like to share something I discovered, which was that although the Arduino Uno is pretty basic, there are actually two kinds of nanos out there. I have a nano right here. So let me show you. I'm gonna go File, Open Recent Blink Examples, Basic Blink. When I do that, I get a program that should blink the onboard LED, and you see me on the side there. There's with my nano. And now then the next step I take, and this gets to be pretty standard for everyone, but it's a great way to start. I select the board, and it's Arduino Nano. It's already selected. The processor stays the same, and the port, which refers to the way to connect through the serial cable from your computer to the Nano, is right there. So we select it, and then we upload it. Oh, actually, what I did this time was I compiled and uploaded it. And you see, if you see the share on my computer, you see it now uploading. It's very important to get started with these things, but all you really need is one Arduino Uno or Nano. Now in the window here, I will bring forward the Uno. This is the old Uno. This one's actually broken, so that doesn't help us much. But now it says here it's not responding. The programmer is not responding. What do I do then? Does anyone know? These things can be kind of tricky. And I think this is a case. I have a magnifying glass here. I'm going to look at the chip on board the Nano. You know, Americans. And look, I am from Doylestown. I was born in Doylestown, Pennsylvania, May 3rd, 1966. My name's Evan Jan Williams, and Joe Biden's president of the United States. Today is the 19th of March, 2022. But all that aside, we get used to things being packaged up for us. But don't forget that these boards are built of discrete chips. And here's an example that you might run across. If I look at this chip, it says Atmel 4809. Now, does anyone know what's wrong with that? So I have a nano here. A nano, however, if anyone studied this stuff, is very similar to an Uno. But this is, in fact, the new nano. And it is kind of amazing when we say new to learn about some of the new technology. The Unos use what is called an Atmel 328 chip. So they're all different chips. And this is something I meant to mention if we went on a little bit, is talk about what a microprocessor is. This other computer, I have a second computer here for my notes. So is everyone happy so far? Could you raise your hands if I'm doing all right? Great, great, okay. That helps me to know. If you bear with me, I think I remember how I changed to the new Arduino. We'll do it together so you can help me get out of the woods that I'm in right now because I have a brand new Nano. I know it works and I need to find the right processor. And the Atmel 328 is the old Nano. So what do we do? I've been in tech a long time. I think the bio is nice for me because in the last year, I've been back in graduate school. So again, I got a data science degree. So I will show you what I do when I have troubleshooting problems. So I hate to be off track, but that's kind of what I'm here for, is to help you guys get up to speed. So I like to go to Google, and or Norton. I use Norton because Norton helps me keep safe on the internet. And I search for Arduino Nano new version IDA, and let's see what that comes back with. Here it is, getting started with Arduino Nano. Now notice, this is right on Arduino.cc's guide. Now, one reason I really like Arduino is there's so many friendly users out there, and it'll tell you, select your board type and port. There are different boards out there. We have to find out about this because this is not the old Nano. It's a new Nano. So I don't want to take all day on this, but let's just say that I have it on my other program here. Let me check. No, that didn't work either. Well, this is very interesting. I'll tell you what, we're going to try one more time together because you can't give up on things that get you stuck. You have to come up to speed. Some of it's about more learning and some of it's about diagnostics. And so I say Arduino Nano 4809 IDA and see what I can get. This is the Arduino Nano Every. So I'm very proud of this new board because it's the first step I've taken to use some of the newer Arduinos that are out there, and there are a lot. But Blink board Arduino Nano Every. So what do we do to get that in our boards manager? I have to go Tools Board Arduino Nano Every. Let's see if we can do that. So I go back to my Blink program. I go Tools, Board. I go Arduino AVR boards. And the Arduino Nano Every's not there. So what do? Now we go to Boards Manager. I was going to mention briefly, you may have been asking or wanted to know why we are not using Raspberry Pi. And there's several reasons for it. One is that with Arduino, we're building specific projects and we don't need an operating system. That's something to think about. Anyway, I'm in the Boards Manager. That's what brought this to mind because I look for Every. So I search for Every and look, it's Arduino Mega AVR boards. So I say install and it brings down the Arduino Mega AVR. Now, when I had a project with a client who needed to build a new clock for the Elks Lodge. It was called an 11th hour clock. And at the Elks Lodge, when it's time to drink, everyone drinks for 11 times, and then the clock rings. So we built it. And while we were building it, I couldn't get the Nano to work. And he kept saying we were using the Arduino Mega. Well, the old Mega is different than the Nano Every. So here we have the Nano Every installed. I go Tools, Board, and look at that. Arduino Mega AVR boards. And there's the Arduino Uno Wi-Fi, which is something I wanted to get started with, and the Arduino Nano Every. So I click that. Now I have the right board installed, and I can go Tools. Port is selected. Resistors emulates the 328. Well, that's okay with me. And I say upload. And it compiles. And it should be blinking in just a minute now. Let's see if it uploads. It's on uploading. Let me see, is it blinking? See, it's blinking. There's a light blinking. Okay, so that's how easy it is to use Arduino. Now here's a project I built using this Arduino. I had a client on Upwork. I can barely, I guess I can show it to you like that. Can you see the project? This is a clock. It uses a little OLED display. It has a real-time clock circuit. And I'm sorry it's so small. Let me go through my slides and you'll see what I have done to take projects forward, and then I can answer some questions. So I have my slides up here. And these did go very well last year. So let me bring them up. And everyone can see them fine, or let me see, I can go, I have to say slideshow from beginning. Okay, this is called product development with the Atmel 328P chipset. And I used the Arduino open source community logo. Arduino is open source electronics. And of course, open source is mostly a term that used to be used with computer software. Until Arduino came along, I didn't really hear about open source electronics. But what it means is that all the you can find out what all the circuits on the Uno are, for example. Oh, we can do a lot of things together today, but let's stick to the slides, and then we can go on further in further directions without getting too far from the center of the concept of building projects with Arduino. So if you're starting out, you may want to just connect some wires to your Uno or your Nano and make a light blink. That's something I can show you. But I have slides here about things I have done to actually pry the chip off the board and put it on a breadboard. So let's go through these. It's very simple, and we don't have to actually do it because I have pictures of it right here. So there's the Uno. And as you see, the chip's not on the board there. And there's a pair of pliers with the chip in the jaws of the pliers. There's been a transition in electronics. And the chips that we used to use were called dual inline chips with pins that had to go through the board and be soldered to the underside of the board. Now chips are all on the surface with the lines like a beetle, and the wires coming out of the chips like legs on a beetle, and they're soldered to the board. It's more meticulous and harder for a hobbyist to deal with. I've learned to deal with some of these things. But here's a case where I had an Uno on an Atmel, that's a Norwegian chip on the Arduino Uno, and I wanted to take it off the board. And so this is the working Uno. And there's the breadboard. I have the breadboard right here. And first I pried off the chip. Then I was ready to put it down on the breadboard. The breadboard's like playing Battleship. The lines go horizontally and vertically, and then you wire them. You have to learn how a breadboard works. I referred to the instruction guide. I got a crystal and put it on. And then you have to be careful not to bend the pins when you do this. It's you can wreck a few chips easily enough. There's the capacitors, and there's the light, and then it's blinking. So that's all there was to it. I did find, however, that the capacitors, I couldn't use capacitors with the breadboard because there was already enough stray capacitance in the breadboard. Oh, to go off board, I had to use my own programmer. Now the Uno and the Nano uses the cable to connect to the board from your computer. But what if you have just the chip, the microprocessor chip itself? What would you use? You can, in fact, use a programmer. I got this from SparkFun. I have one right here in my hand, and we can try all this. But I think if you're all pretty new to Arduino and you want to use Arduino to blink a few lights, maybe you are here because you had a project you wanted to build. Let me take it a little slower here. That's a breadboard that I put together to test some USB circuits. And then I was able to, just to cut back to the slides, I was able to prototype a circuit on the breadboard and then wire it, hardwire it on a solder board, create a schematic, and create a printed circuit board. So that's been a project of mine for a while. We have some time, so I need questions from you. Are you all pretty new to this sort of thing? Maybe what I can do for you is start building some circuits and show you what I do to just create a few simple circuits together. So let me see if we can share stop the share here. Great, and now you should see a bigger view of me. Is that correct? Great, thanks. So so now here's the Uno. This Uno is not working. So I want to get blink working off from the Nano here. Oh, here we go. The project I have in mind is to carefully, hold on a second, I need to see that question. I need my glasses, here we go. To carefully bake reel-to-reel audio tapes. Use an Arduino temperature and humidity sensor, a real-time clock, and an incandescent light bulb as a heat source. Now that is a great idea for a project. So one thing I often do when I'm prototyping projects of this sort is to start with the blink. Because if you get it to blink, you know that you're programming it correctly. I have done things with all these little pieces. So let's get started, okay? So what we have here is a blinking LED. I'm going to carefully take the Nano off. I'll hold it, I'll do it in front of the camera. And let's see, I have enough light here. And we'll just sort of set the Nano into the breadboard and carefully press it in, okay? So that's step one. Then what we're going to do is get an LED to blink. And this is going to be what you're going to go through with all the parts that you're going to wire to your bake monitor. So so then I have a light emitting diode here, and you have to carefully look up what side is the anode and what side is the cathode so that you don't reverse bias it. In other words, the cathode, or maybe you could correct me on this, the cathode is wired to ground, and then I have to see what pin we were using. So let's go together to the documentation. So what I'm going to do is share screen again. And let me get my browser up here. And then remind me to take it easy and relax, okay? Because I do better as a presenter when I just relax. So I'm now sharing my screen again. And what we're gonna do, since I'm not using the Uno, but I'm using an Arduino Nano Every. Am I in the right place? I'm in the browser, right? Good, so I go Google, Arduino Nano Every pinout. And then there's so much out here. It's really wonderful, but here's the first one I'm going to look at. There's the board I'm using. And if we, oh, here's the specs on it. And there's all the pins. Now, one thing we have to do is make sure these pins correspond to what we wrote in our program. Now, just as an aside for you guys, since I know it's important that your projects will work, is that, and Catalin pointed out that there are different ways to program Arduinos and other computers. This is actually C++. So it says LED built-in is output. Let's read through the code together. But the important thing is, it's not C, it's C++. It's object-oriented programming. I'd like to touch on that briefly. I have some time. Let's finish our little blink example, and then I'll try to go further in helping to engineer this project. So what is LED built-in? If I want to build if I am blinking a onboard light, which one of these pins corresponds to the onboard light that's blinking? I think it's pin 13. We can either guess or we can look it up. It's better not to guess if you can help it. So there's better references on the web, but I will search for Arduino Nano Every built-in LED. And if I do that, it says built-in LED not working. That sounds like a good place to start. But what pin would it be on the what would the external pin be? Pin 13. These guys seem to think it's pin 13. So what I'm going to do is wire the LED to pin 13. But I want you to be aware of, with electronics, to watch, we have to be careful that we don't exceed the voltage on the LED, which might be about 2 volts or 3 volts maximum. So to make sure we're safe, we have to use a resistor. So Catalin already showed us how to read the resistances. So let me go back to design mode here. And so stop the share. Is everyone happy pretty much? Good, that's what I want to hear. And I zoom right in here. Oh, okay, this goes on a lot here. It's close enough that I think you can see it looks black, black, red, or is that brown, black, red? It's actually brown, black, red. Brown is 1, black is 0, and red is the 1000 multiplier. There's also there should be silver on it too, which means it's a 5% tolerance resistor. It's not a military grade resistor or anything. It's just a normal resistor. What is a resistor? Very important. Impedes the flow of current so that when I put the LED diode, here's the LED diode, and I put the flat. There's a flat side. I place the flat side onto my ground lead. Oh. See, let me just do that first. So the flat side goes on the ground lead. And now I have the LED diode wired to the breadboard. Then I take the resistor and pin 13 on the map here. Let's go back together to the map. Let's see here. I have to see if I can share my screen again. And then I'll just quickly wire it for you guys while you take a little break. And then let's see here. Where's the diagram? Okay, so you can just study that for a minute while I wire this and talk about what I'm doing. And so what I'm going to do here is, if you see in the top left corner, it says D13. That means pin 13 is also the built-in LED, and that has to be wired to the anode of the LED. I get them confused. Diodes are tricky. The arrow and the symbol points from the anode to the cathode, meaning that it's forward biased. And these are all things you have to learn, but you have to start somewhere. So you have to learn how to put the diode in correctly. And then the last thing we need is make sure we ground the board. So I'll find another wire here. Oh, here's what I'm doing so far. And then I have to, on this diagram, it also shows where ground is. Ground is actually one up from the bottom. So I put ground up and one up from the bottom. And then if I plug this in, that light should blink. Let's see. If I plug it in. And it's blinking. That's real nice. So then we stop the share. So to stop the share, I go here. And there is the completed circuit. So we've used the same program. We haven't uploaded a new program, but now in addition to blinking on the Arduino Nano Every, it's also blinking on the onboard LED. So that's a good thing. To go further with this and use temperature, humidity sensors and a real-time clock is easy enough. You have to read up on each of the sensors you want to use. I can't do that right in the talk right now, but I could start some topics that will help you. Does the Nano Every support 5-volt inputs and outputs or 3.3 volts? I would suspect that most of the voltages, they support Nano Every. Well, let's find out together with the specifications. I think it's 5 volts because I did use the resistor, so I dropped some of the power, and the light emitting diode would not burn out. So I'm pretty sure it's 5 volts. But let's find out together for an absolute fact. So if I stop the share, let's see here. I'll share my screen again and go back to that page we had. And one thing I like to do when I give a talk is actually copy the URL, because this was very helpful. I'll do that later and send them to Catalin or to Al, or both you guys. Here we had the specifications. So let me see. It should say current per pin is 40 milliamperes. Oh, only 20 milliamperes on the every. You can't use these to drive a lot of fancy circuits, but that's, I mean, without some sort of power transit. Operating voltage 5 volts, and we'd have to go deeper into the specifications to find out. One thing it says here is DC current for 3.3 volt pin, 50 milliamperes. I don't know if that means the outputs are 3.3 milliamperes or not. So we'd have to get the data. Let's do that right now. Get the data sheet. And now we have the data sheet for the 4809 chip. And electrical characteristics are right here. We have to learn to read these together. Power supply voltage, current into, and let's see if we can have GPIO voltages, min and max. Let's see here. Oh, it gets so confused. IO pin characteristics. VDD plus, so the voltage level, VDD can vary. So input voltage can go up to VDD, which is 7 to 21 volts, and the output voltage I may not get the answer for you on the first try. I'm sorry. Let's see here. Here we go. Output low voltage is only up to some fraction of the high voltage, but the output high voltage should be here on this page.
Yep, I think you had it right there. There was somewhere where it said 3 mils output current, and with that, you won't see an output voltage higher than 0.4 for a low.
Okay.
It promises that you won't have a voltage increase greater than 0.4 volts if the output current is limited to 3 mils. I think that's
okay.
You had pulled that up a second ago.
You're going to have to do some more research and make sure you're reading it carefully. I'm glad you. Yeah. Oh, you did see it further up here, right?
I thought you had it for a second. I could maybe I'm wrong. Right. It was going kind of quickly, but it was IOL that I was looking at. You had the output low current.
Who is talking right now, by the way?
This is Larry Perlstein. Sorry.
Oh, hi, Larry. Right.
Oh, yeah. I'm sorry. I should have unmuted.
That's okay.
As well. Yeah.
Oh, great. So you did find an answer there.
I believe that, well, at least when you were scrolling there, it looked like you had. If you search for IOL, I think that may be what.
Oh, okay. IOL.
Yeah.
Oh.
Well, there's VOL. That's different values of IOL, right? But they had it was on the left side.
Here it is right here. Yeah. So for VDD, it depends on what you drive the chip at. Mm-hmm. At 5 volts, the minimum is going to be a 4 volt output. It looks like VOH, V output high. So that's the parameter we are looking for. So these are important things because you can burn out your equipment, and the stuff is the chips and LEDs are expensive now.
Absolutely.
Yeah. So that's good. Very good question. I do have a project here that I has a real-time clock on it. It's actually a clock, as I mentioned. And I thought it would be nice, since we've covered everything else, to talk about the programming a little more. You know, it's great to get started and just make a light blink and then get a push button. Soon you have the push button goes, the fade works, everything sort of works. And it's good to know how the electronics works inside. I taught Arduino programming, embedded development, and you have to cover so many things. It's good to talk about how microprocessors operate. Let me talk about how microprocessors how that the basic Uno microprocessor operates for a minute, and then I will talk about C++ programming, and then I'll be done, and we'll both be able to handle some questions. How does that sound? So let's Google. I want to Google two things for you that are really very important. So most of us are going to still be using the Uno for a long time, I feel. Arduino Uno, there it is in my search. Oh, I said I'd Google it, not Norton it. So I better stick to my word, hadn't I? Arduino Uno. And I want to go to Uno, schematic. Arduino Uno reference design. This is the circuitry that's on a standard Uno or a compatible Uno, a friendly, Arduino friendly. We are not allowed to use the term Arduino. It is open source, except you see that Arduino is trademarked, TM. Don't complain too loudly about it. It's nice that the electronics is open source. But I built some devices and I could not call them Arduino compatible. I was allowed to say Arduino friendly, or it did say Arduino friendly. The term Arduino is trademarked, but for an open source forum like this, it's free to us. That is the circuit for all the chips that are on this board right there. And it's a good link to have. The other thing to do is to look at your microprocessor. If we do that, let's search for Arduino Atmel 328. Now, how do you know what microprocessor is on your board? As I mentioned, you can get out your magnifying glass and actually read the fine print that's on the chip. And if I do this, I find that it's on the Uno, it's the Atmel 328P. So I say data sheet. Looks like my cat is happy now, so we're in good shape. My cats. And here's the data sheet. Right. I don't want to see it like that. I just want the data sheet. What do I have to do for the data sheet? Well, here it is. Here it is. Oh, we were just at the data sheet for the 4809. But here I want to show you the core. This is the crucial picture for understanding how microprocessors work. You know, Raspberry Pi or Arduino, they all have something like this going on. And I don't want to go deeper than we should in a workshop right now. Just take it. Just let me say that you see that heavy, the dark line, the thick line is the data bus. And as you write programs in C++ and they turn into assembly code and get uploaded as bits and bytes on the wire, they make things happen between the different modules that are pictured here. It's called a block diagram. And it corresponds to what you were seeing in the in this picture. So in other words, if you're blinking an LED, if you're uploading a circuit or blinking an LED, you have to identify which one of these is the Arduino chip. And then, did that magnify? So once it's uploaded, pin 13 is actually one of the wires off of the Arduino chip. But how does it work? Inside, you can read more about it, learn how the signals pass back and forth. And there's multiple sketches here. There's another sketch that actually shows in detail what the registers are doing. But it goes on and on, so I don't want to go too far with that. But let me talk about C++ code for a minute. I have a clock circuit here. I go back to my Arduino IDE, and it's a pretty nice, my client was happy with it. Let's put it that way. Close this window. Help. Now, how do I close this window? So, and then can you still see my screen? File, please move this window away from the shared application. What is going on? Wow. Okay, file.
I think you're just sharing your browser. You're not sharing the IDEs.
Can you see it now?
We cannot.
You cannot. Oh, so let me new share. And I want to share that. How's that?
Perfect. Thanks.
Okay, great. So now let's see if I can find the clock. This is good for me. Now, Arduino puts all the files into one, all the sketches into one directory. So if I say open, I should be able to find the clock circuit I had built. Let's see if I can find it. Oh, yes, there it is. Here it is. Okay, so now this, just so you know what to do, this Arduino Sketch is located where my Arduino sketches are stored, obviously enough, and this PC documents Arduino. And then within it, the folder has to be named the exact same name as the sketch inside. That's a rule of the ID8. So I opened Nassoon. Mr. Nassoon was my client. I built the clock for his daughter, so she'd know how to program C++ code. And there's the sketch. So then what we're going to do here is see if it'll compile on the every. So I go tools, I set it to every, and then I have to, the every's plugged in right now. I'm going to the first check mark is for compile, and the second one is for upload. When you upload, it also compiles. So why would you just want to compile something and not upload it? This sequence of compilation and upload is really very, very important in programming. And you may make a small change and want to see if it's going to work. And then you upload it. Let me upload it. It actually compiles it again in Arduino. But some of the compilation may already be done. There's important distinctions to know about. But at any rate, that's what those two buttons do. And then it's actually working right now. And I'm going to put it in my, I have here on the side, you see that I have the device, the circuit, the wired circuit that I built for this clock. So let me plug it in there and see if it works. Okay, it's done uploading. So for me, Arduino's been the thing I do. It's been something I've been happy with. I haven't gotten very far into Raspberry Pi and all that operating system stuff anymore. I just programmed this with this clock. What I'd like to do next in the next 10 minutes or less or more is I'm going to take this off the board, plug it into that circuit and see if the clock circuit works. And then I just want to go through the code with you to show you how, a reasonably good implementation of a circuit that uses a real-time clock actually works. So I plug it in. Let's see here. Well, it all lit up, but the screen didn't go on. Oh, well, back to the drawing board, at least it lit up. I don't know why the screen didn't go on. I guess there's something missing, okay? Let's go over the circuit, the code, however, and talk about what I'm doing here in the code. So taking it from the top, this clock is supposed to have two push buttons. It's supposed to have a display, and it has a real-time clock itself. So let's see what's going on in a fast way, so you can understand the mechanics of writing a C++ program in Arduino. The first thing is you notice there's a lot of these things called include. What are include? These are actually the different libraries that are used in the program. Now that's in computer programming, it's all about language. And there was just so many words in there, libraries included in the program. We all know what the library is. It's a place where you go to take out a book. On computer programs, however, you go in Arduino, you go Sketch, include library, and look at all those libraries. One of them is the library for the real-time clock. Let's see if I can find it down here. If I find it, however, it just all it does is put in the reference for me. So here, DS2321, I think that's the real-time clock. You have to read about how to install libraries. After that, I go through a section here where, as Catalin mentioned, there are variables, and some of these are called int. They are small variables. They're only 8 bits wide. Of course, the Arduino itself is an 8-bit computer, but you don't have to have a number that's limited to 32767. But with int, it does. If you want a larger number, you have different choices. Here's double. You can have long. You can have word. But all the global variables are defined here. So that's an important other keyword for you, are global variables. Then what do? I define a constant. A constant is not a variable. A constant is a moniker or a shortcut for your program. So when this OLED reset comes up later and is in the program, it's not a variable. What does that mean, the difference between a constant and a variable? It means that when the compile, let's control F and find OLED reset. Oh, there it is. Next line down, Adafruit SS1306 display, which is a nice OLED. It's not very expensive. It's about $5. OLED reset. The compiler says, I already know what OLED reset is. You told me it was supposed to be equal to 4. So I'll put that in right now and save you the work of putting it in a variable. A variable, however, like one of these up here, actually becomes a number that is live on the Uno or Nano when it runs. So now let's go on. Setup. Setup is a entry point. It's like a function here. It's a special function where everything begins. And in this function, I begin something called wire, which is the way to communicate. I begin the real-time clock. I set some variables. These are not constants. These are real variables that are become memory locations on the computer. And then I start the display. After I start the display, I'm setting pin 13. That was our onboard LED to be on. I'm doing that for some reason. I guess I wanted it to blink or something. And then I start the loop. So this was all very fun to program, but loop is another entry point. So there's 2 important entry points in the C++ of the Arduino. One is setup, where you set the stage, as it will. One is loop, and loop constantly repeats. As the Arduino runs, it constantly repeats the loop. There's no other operating system on Arduino. This is why it's not preferable to Raspberry Pi or some of the other embedded boards, but it takes all the operating system, all the Linux, everything out of it. And all I'm doing here, step 1, I'm blinking the LED. Step 2, I'm reading the push buttons to see if they were set. Step 3 or 4, I'm going to my clock read time, and I'm going to my clock display time. What is going on here? This is actually C++ code that I wrote. And just because there's only a few minutes left, I'd like to show you how C++ code works. There's a header file, just like the libraries, in which all the functions, and this is stuff I was able to write, all the functions you need are there. And then in the like erase string or display clock, and then in the CPP file, they're all explained. So it's very simple, and it means that you can write programs that are like cookie cutters. Here, clock OLED set alarm. Here's what I do to set the alarm. Everything pertaining to the clock is in here. So it's really a very powerful system. And I think Arduino is going to be around for a while. That's all I have. And thank you.
Thank you.
Great, thanks very much. We we have quite a few folks here. Any questions? So maybe I could start. I'm sure there are other folks that have questions. I don't know if anybody's hesitating, but I'm kind of curious to hear what your feelings are about the different platforms that you could use. The Nano versus the Uno versus like some of the Adafruit versions, the Trinket and so forth, and the Mega and all the different variants. Have you tried any of the different ones? Do you have a favorite for performance and price and so forth? What are how do you make your decision what to use?
Is that for me?
Yes, yes.
I can take
well,
that.
or Catalan, either one, but yeah.
There's a lot of boards out there, and you can spend a lot of money. Part of it is that every manufacturer kind of wants to make their own board, and I know SparkFun has a SparkFun Red, which might be Arduino friendly out there. My feeling is if you're getting started, just get an Uno or a Nano and get started. It's great. Then the point is, do you need to upgrade to a bigger board? And you find that question out by trying some projects and seeing, are you running out of memory? Is it performing fast enough? Remember, say you want to use analog to digital conversion for your temperature measurements. The Arduino only has 8-bit A to D. I think that's correct. You could do better with some more professional board, and it really gets, there's so many boards out there. One resource I found was Make Magazine. They have an index of so many boards so you can make a more informed decision. It's great to do that.
Mm-hmm. Terrific, yeah. So what other, and I guess, by the way, just to mention, like one of the things, and I don't know if you mentioned it, but the Uno, there's that standard shield form factor for like adding hardware, whereas a lot of the other ones don't conform to that. So not if you want to add shields, you are somewhat limited, I think, right?
Well, I'm curious about that. It seems as if the Uno is still around. I didn't go to their website lately to see if I could buy a new Uno. I'm sure I can, but I'm not sure of it. But there's an Uno plus Wi-Fi out there, which it is a very standard form factor. It seems as if the Nano is used quite a lot now, though. And for that, for the Nano, you would have to put it on a breadboard and connect the wires. It's not as easy as with the Uno, is just plugging wires into it and watching it, letting it go from there. But definitely, it's a standard that it is around, and so many boards that compatible or related boards that are not Arduinos use this footprint. So it is a standard and very important.
Other questions? Yeah, there's a comment in the chat. I don't know if you're looking at that, Evan, but it looks like Herb says, does the Nano? Let me see where the questions start. Actually, why don't we start first with Eddie's? You want to take that one first?
Oh, well, he really helped me get started here. I tried to answer some of those sort of questions.
Okay.
Let's see here. I've used a real-time clock. Which real-time clock is it? I can leave my email for him. Do you want me to put my email down there, or yeah, some of those questions are best handled offline, in terms of specific project. There's so many ways you can handle something like this. In other words, if you don't have to be too complicated. I have used a temperature and humidity sensor that's out there, but I imagine you could also use a thermistor if it's calibrated. And I've wanted to go to that length to actually compare the different ways to measure temperature. In other words, there's Adafruit has a nice DT. See, I don't remember the actual part number of it. I think it's the one I have in here. I'm not sure. I'd have to look this up, and there is a nice real-time clock out there, but I don't have the references for them out here right now. Let me see what some of the other questions are. We covered that one. Does the Arduino software platform, excuse me, is it compatible? You know, it is kind of true that they are compatible, but I've had a lot of problems, excuse me, switching from the Uno to another board. There are a lot of differences, and as you move along, sometimes it's not as compatible as you would think. So, yeah, you have to look at the board you have and see what's going on. I'll tell you a funny story that may help you understand how to think about these projects. I started with Uno 5 years ago or so. And, you know, I'd been in programming for a long time, and I kind of thought I knew it all. And I thought, wow, these shields are great. I can just get several shields and stack them up, right? Well, you have to make sure that the lines don't conflict. If you have a shield that measures temperature instead of a device that measures temperature, and you've got the library working, you can't just put on the shield for the real-time clock. Now you have a stack of pancakes.
You're saying if they use like the same output pins, or they
same output pins, absolutely.
Yeah.
So you have to double check all these things. The same goes for you say to me, well, I have a nice shield or daughter board that works on the Arduino Uno. Can I use this on the Mega? Yes, but there may be some changes. Now, one issue I had was I like to use an LCD display. There's nice LCD displays out there, but guess what? You put them on the Uno, they've used nearly all your pins. So then you have to go to the Arduino Mega. Where does your other shield go? It can't go where the existing shield was.
So I wonder if you or anybody has heard or had experience with the Raspberry Pi Pico. That looks really interesting. It's a Raspberry Pi, but it's really nothing like a Raspberry Pi. It's basically a no operating system, simple ARM-based microcontroller.
Well, it seems that I saw one video on it. It seems that they received Massimo's blessing or whatever it takes.
Oh, so it's going to be Arduino compatible?
No, I don't believe it's an Arduino.
Oh, okay. They won't make it compatible.
But it didn't seem like it was a Raspberry Pi either.
Right. It's not really. I mean, it comes from the Pi Foundation, but it's not.
Right.
It's not. Linux based. It doesn't have.
No, if I had one, I'd be happy to investigate. Oh, the other thing to know is I asked the question, what is an IDE? Well, actually, the Raspberry Pi, is it called the Pico?
Right, the Pico, yeah.
It may work with, Microsoft has a nice IDE out there now that programs Arduinos and Raspberry Pi and probably the Pico. So, there's definitely alternatives. I've looked at several of the alternatives. It's been a while since I haven't looked at the current set out there. Certainly, if I had the boards, I'd be happy to do so.
Yep, it doesn't look like it's nearly as easy to work with as Arduino, like based on a little bit I've looked at. But it's $4 and very capable microcontroller. So it's they're inexpensive and very, very high performance.
Oh, that's really good. I have started with ESP32, which is a Chinese brand.
Right. They're really great for wireless, right? They have built-in wireless for
right. And then, of course, as I mentioned, Arduino is not as powerful as you might like. It's kind of a toy, so maybe the Raspberry Pico is better for some things or newer. I know Arduino is probably trying to keep up, but one nice thing that seemed to happen with the Pico is they didn't start a big, they're apples and oranges. There's not a lot of it's not a technology war of any sort.
Right.
But I have looked at other boards. I've looked at, you know, there's boards for signal development, Red Pitaya and stuff. There's better DSP boards. The Arduino does do digital signal processing, but I think there's some limits to its speed because it's only got a 16 megahertz clock. So I looked at the TI boards. Texas Instruments has some wonderful boards there. So, and then of course, if you're in Raspberry Pi land, there's Banana Pi and all that stuff. So you can really go quite far with on Raspberry Pi, but that's using an operating system. So something like the Texas Instruments boards are giving you better, or Red Pitaya, which is just something I know about on the side, are giving you or Texas Instruments MSP 430. They're giving you better real-time clock. They're giving you better analog to digital, and you're programming them and say they're not programmable compatible with Arduino, but it still is C++, and there are some good resources there.
Sounds good. Any other questions? Maybe it's probably a good time to start wrapping up, just to give us a short break before our next speaker.
Just to note, here's Carl Kruger, who says you can program a Pi Pico from the Arduino IDE.
Oh,
so I wasn't totally wrong about. Thank you, Carl.
That's good to know. Yeah, I would.
Yeah,
I'm gonna check that out myself.
I thought I'd gone out on a limb there.
Mm-hmm. Cool. Thank you, Carl. Yeah. All right. Let's thank our speakers. They were terrific. Thank you, both Ketelin and Evan. And